Hey students, greetings of the day. This is your physics teacher, Yani Rao, and founder director of VIP classes. Okay, so let us try to solve these numericals actually. Now, first series we have done work energy power complete basics we have done, isn't it? Complete work energy power theoretical part, and let us solve few numericals based on here. You see in this question, body moves along west-east direction to east direction if coefficient of static and kinetic frictions are like this. The work done by frictional force in displacing the body. So if you consider body is going east to west direction, right? So now for example, let this you can draw the directions here: east, west, north, south in a plane, west to east. So left to right it is going. So now when the body is going from you can say left to right or west to east, frictional force will oppose the motion, isn't it? So work done by frictional force is frictional force in displacement into angle between force and displacement. Displacement is rightward, frictional force is leftward, angle is 180. You can write cos 180. Yeah, this is kinetic friction when the body slides, isn't it? So this is mu k into n into displacement. Displacement, how much he said? That is 0.5 meters into cos 180 is minus 1. So we'll have negative work. So minus mu k value is 0.2 given. And normal reaction, the body is moving here. So normal reaction is upward, weight will be here downward. So n will be equal to mg, students, right? So mass how much given? That is 2 kg, g is 10 into 0.5. So this decimal get cancelled. So how much will have? That will be equal to 5 to the 10, 10 into 0.2, that is 2. So that is minus 2 joules is the work done. Why negative? Friction is opposing the motion. Okay. So here minus 2 joules is the work done. Fine. Next you can see. He's mentioning a body of mass 5 kg is lifted against gravity. This was a previous questions diagram. Yeah, a body of mass 5 kg is lifted against gravity, vertically upward, for example. So some displacement, okay. The work done by gravity and the person. Say he is not mentioned. Let us say displacement is 1 meter. We can say. Assume displacement is 1 meter. So the body is moving vertically upward. In order to lift the body up, minimum force we have to apply equal to its weight, mg. That is 5 into 10 you can write, which is equal to 50 Newton. So here two cases: work done by applied force. Work done by applied force, how much? Applied force is upward and displacement also upward. It is doing positive work, isn't it? So that is equal to minimum force is 50 Newton into 1 meter. You can say it will do 50 plus joules. Okay. Now work done by gravity. When you are lifting it up, okay, gravity will be acting vertically downward. That is equal to mg, and displacement is upward. Okay, f is equal to h upward. So both are opposite. So work done by gravity is negative in this case. So minus, which is mg into h. That is 5 into 10 is 50 into h is 1 meter. So gravity will do negative work and applied force will do positive work. Okay, gravity will do negative work, applied force will do positive work. Okay, just order is important here. So minus 50 and minus 50 is gravity, applied force is 50 joules. Okay, right. Now you can see, choose the correct statement. Work done by gravity is always negative. Is it true? Gravity will do always negative work. When you are lifting against gravity, gravity will do negative work. When you are dropping an object, when you drop an object here downward, what happens? Gravity is pulling it. So gravity doing positive work. So need not be do always negative work. Okay, this option is wrong. And next is saying frictional force is always negative. Need not be. Sometimes friction may support the motion. For example, you have a plank. Okay, an object is placed over. When you are moving the plank, object may also move along with the plank. So why the object is moving? Because of friction between plank and the object. So friction is supporting the motion here, isn't it? So of course, which opposites relate to motion with respect to plank, the different issue. Tendency of skidding, this one is backward, so friction will be forward here. Okay, so friction will do positive work here. So friction need not be do always what? Negative work. Okay, this also work done by friction for always negative is the wrong statement. Work done by normal force on a body moving in horizontal direction. The body is moving in a horizontal direction. Normal force acting perpendicular like this. Body is going like this. So normal is always perpendicular in this case. So work done by normal is 0. So this is the right answer, C option. Okay, right. Next you can see body of mass 2 kg is moving along this path OA, B, C, D. So he's asking work done by gravitational force. So O to A, if you consider, students, O to A, body will move horizontally. Okay, displacement is horizontal, but gravity acting vertically downward. Angle is 90 degree. When angle between force vector, displacement vector 90. How much work done? 0. So work done during this path is 0. Next, A to B. So here A to B, if we consider A to B, body is going upward. Gravity will be acting downward. Mg. So certain height h is equal to 2 meters here given. Okay, so gravity will do what work here? So gravity will negative work. So that is minus mgh. Okay, now B to C if we consider. So B to C, okay, B to C displacement is like this, but gravity is in this way downward. Again, angle is 90. So work done by gravity in this case will also be 0. And next, what work done from C to D? C to D will be, see students here, C to D displacement is downward, gravity also downward. Gravity is doing positive work, displacement equal to 2 meters, that is h. So you can say C to D also mg into displacement is h is equal to 2 meters, so plus mgh. So if you add 0 minus mgh plus 0 plus mgh, these two again get cancelled. So total work done in OA BCD path, how much beta will comes out to be 0. Getting? So right, so here just I give the question based on displacement direction and force direction. Okay, yeah, stone of mass. Next question is the fifth question. Is rotated in a horizontal plane with a constant speed of 2 meters per second by means of a string of length 0.5 meter. Okay, work done by centripetal force asking. So in a horizontal plane, when you are revolving along a circular path kind of fashion, so everywhere you can see centripetal force always towards center seeking force we call, isn't it? So everywhere towards center. But direction of displacement is always what? Tangential direction, always tangential direction. So tangent and this particular what? Radial direction, always they are what? Perpendicular. So work done by the centripetal force is F S cos 90 degrees, that is equal to 0. Same thing we have seen, work done by gravitational force of the earth in revolving the moon. In theory part we have seen already, isn't it? The work done by gravity is 0. So answer is what here? 0. Now coming for motor vehicle of mass 100 kg is brought to a distance of x meter by applying brakes. So work done by braking force, the uniform acceleration of body is minus 10 meter per second square. Initial speed is 36 students. So 36 you can convert in meter per second. 5 by 18. This becomes 10 meter per second. Initial velocity. Of course, final velocity is 0. And retardation is mentioned here, right? Yeah. Uniform retardation is 10, acceleration is minus 10. Okay, so you can write here acceleration is minus 10 meter per second square. So how much displacement you can do now by third equation? V square minus u square is equal to as. Yes or no? So s will be v square is 0 square minus 10 square divided by 2 into a value how much? A value also minus 10. This will be 10 meters is the displacement. Okay, now asking what are rest of the distance of x meter or braking force. So work done by braking force is equal to how much amount of force acting you can find out. Retarding force, how much? Retarding force is mass into retardation. Retardation means negative acceleration. So mass is 100, retardation is minus acceleration is minus 10, retardation is plus 10, which will be minus 1000 Newton. So retarding force into displacement. So minus 1000 in displacement, how much we got, student? 10 meters. This is Newton meter joule. So minus how much we'll get? Yeah. Oh, one more 2 is here, no? So by 2, this will be 5 meters, students. So this will be 5. That means how much? 2 ones are 2 5s are. That is minus 5000 joules or minus 5 kilojoules. So S value here by 2. Okay. So 5 meters. So you can substitute here. So why negative? It is opposing the motion. Okay. Therefore option B is right. Now next question you can see here. The force acting on a body of mass 0.5 kg at rest is given. Okay, as a function of time. Answer the following questions. Yeah, this question based on area under FT graph. Already we discussed area under FT graph. Area under FT graph gives what? Change in momentum. Right? So now 0 to 2 seconds. The velocity at the end of 2 seconds. Just consider area up to 2 seconds, students here. Okay. So this is a triangle area. So mass is 0.5 into velocity. See m into v minus u. mv minus mu. Final momentum minus initial momentum. That is change in momentum is equal to area under FT graph. Triangle area. So half into base is 2. Height of the triangle is 10 students here. So this is 0.5 into velocity starting from rest. So initial velocity is 0, which is equal to 10. 0.5 is 1 by 2, right? This is 1 by 2 into v is 10. So v will be how much, students? V will be 20 meter per second. So at the end of 2 seconds, velocity is 20 meter per second. Next, you should see what is asking. The change in kinetic energy of the body when constant force acts on it. See from the graph, constant force start acting from t is equal to 2 seconds to 2.5 seconds. So during this time, change in kinetic energy. So at t is equal to 2 second velocity, just now we found 2 seconds is 20 meter per second. Similarly, again you can find area under this graph, rectangle 2 to 2.5 seconds. Okay, so what will get? Change in momentum again. So mass is 0.5. Final velocity we have to find out, say v or v dash as you wish, minus initial at t is equal to 2 seconds is 20. This must be equal to area, rectangle area, length into breadth. This is 0.25, 2.5 minus 2. This is 10 students. So 10 into 0.5. This will be 5. So this is 1 by 2 into v dash minus 10 is equal to how much will get, right? This is 5. So v dash minus 10 is equal 20 is equal to 10. So v dash will be is equal to 30 meter per second. You are getting? So what is asking? Change in kinetic energy is asking, right? So when a constant force acts, so we know velocity, initial velocity is 20 meter per second at t is equal to 2 seconds, isn't it? So and here 30 meter per second at 2.5. So you can find change in kinetic energy. So half into m into final kinetic energy minus initial kinetic energy. So half m square will get. So half m value already we have seen 0.5 kg, right? Yeah, 0.5 kg into v2 square is 30 square minus 20 square. What will get? Yeah, simplify. 0.5 is 1 by 2, 1 by 22 how much? 1 by 4 into 30 a square minus b square you can use. 30 plus 20, 50. 30 minus 20 is 10. So 2 2s are 2 5s are 2 1s are 2 25s are, that becomes 125 joules. Okay, this is the answer. So based on area under ft graph gives what? Change in momentum, you are finding the velocities, and accordingly you are finding constant what? Change in kinetic energy. Displacement covered by the body during constant force acting. Yeah, you know initial velocity during constant force, final velocity also, and acceleration you can find out constant force acting, no? So constant force means acceleration also constant. How much constant force acting from the graph, students? That is 10 Newton. 10 Newton by mass is 0.5. 0.5 means 1 by 2, student, which is equal to 20 Newton per kg, no? That is meter per second square, right? Acceleration, no? So an initial velocity t is equal to 2 seconds is 20 meter per second, and at 2.5 seconds we got 30 meter per second. You can see the previous here, see 30 meter per second, here you can see 20 meter per second. Okay, so you can write third equation, v square minus u square is equal to 2as. So from here s will be v square 30 square 900, u square 20 square 400 by this 2a will go this side, no? 2 into a value how much, right? 20. So s becomes 900 minus 400 how much, students? 500. 500 by 40, 50 by 4, that is 25 by 2, which will be 12.5 meters. Okay, so this is the answer. So directly from the graph you can do. Okay, now you see an object is also displaced along an inclined plane. The work done by the force of gravity. See, two ways we can do this question. So along the inclined plane, so this angle say 37 degrees, students. So this is 3 4, no, this becomes 5. Why? Pythagoras theorem. Okay, 3 square plus 4 square is equal to 5 square. Yeah, so when the object is moving down the incline, you can resolve this weight into components. Why you have to resolve here? Because only gravity acting vertically downward here, so but component of weight will act which displaces the body along the incline. So that's why I am resolving into components. Okay, so already we have seen resolution. Now mg, so if I resolve, this is theta, this is 90, this is 90 minus theta means 90 minus 37, so this will again be 37. Okay, or you can say this as theta, this is 90 minus theta, this one, this again theta. So if I do mg into component, mg component perpendicular to incline, this direction becomes mg cos theta, we have seen already. And along the incline will be how much, students? In laws of motion series I have done, and as well as vectors also I have done, components, mg sin theta. Now you see, when the block is moving from top of the incline to bottom, along the incline displacement is 5 meter. Along the incline force is mg sin theta. So work done by gravity will be here. Gravitational force along the incline is mg sin theta. Displacement is 5 meter. So you can write down, this is mg sin 37 is 3 by 5 into 5. This becomes here 3 mg. This is one way of doing. Another way of doing, you see, students, all of you diagram. See, so block is sliding along the incline, right, like this. But how the gravity acting? Gravity always acting vertically downward. So in the direction of gravity, how much displacement is? This is displacement, that is 3 meter. So our definition we have seen. So work done by gravity is gravitational force into displacement direction of gravity. How much? That is 3 meter. So this is mg into 3 meters 3. This is equal to 3 mg. Okay, both the ways you can do. Clear? Fine. Now next you see, choose the correct statement. He's saying mechanical energy of a system is sum of the potential and kinetic energies. This is right. Work done by external force on the system is equal to increase in its kinetic energy, say for example. Okay, so yeah, work done by all the forces or net force is equal to change in kinetic energy. Work energy theorem statement. This is also right. In a source of energy, so like a cell or a battery, chemical energy is converted into electric energy. Obviously true, everyone knows this one, right? This statement also right, students. Yeah, in case of simple pendulum, at its mean position, total mechanical energy is kinetic energy at its mean position. Yeah, in simple pendulum case, if you see, when the bob is oscillating about this mean position, if I take reference line over here, it is going this side, again coming to mean position, going extreme and coming here, one oscillation over. If I take reference line here, and this height is h. If I take here starting from rest here, so body is sliding, body is moving here like this. When it comes to mean position, reference almost height is 0. So here potential energy at this point A converts into what? Kinetic energy at point B. Again when it goes to C, again kinetic energy decreasing against gravity. So potential energy becomes maximum, kinetic energy becomes 0. Already energy graph also we have drawn. You can see my series, work energy power, first video. Okay. So here kinetic energy extreme position to mean position, kinetic energy increasing, potential energy is decreasing. So in case of simple pendulum mean position, total mechanical energy is called kinetic energy mean position, you can say. Okay, so almost all statements are getting right. Okay, so fine, students. Next you can see 1 horsepower. All of you know, should remember this one. 1 horsepower value how much? 746 watts. But kilowatts is asking, divided by 1000, that is equal to 0.746 kilowatt. Okay, this is first answer. And 1 kilowatt hour, how many megajoules? 1 kilowatt hour. What is kilowatt hour? It is commercial unit of energy. Why? Power we defined as energy by time. Energy how much beta? Power into time. So power is in kilowatt, time is in hours. That is called kilowatt hour. Okay. So 1 kilowatt. Kilo means how much? 1000. This is watt. Hour means 60 minutes. This is 1000. Watt means joule per second. 60 into 1 minute also 60 seconds. So this second cancel. How much will get right? 36 into 10 power 5 joules. Or into 10 by 10 if you do know. So this also becomes 36 by 10 means 3.6 into 10 means 10 power 6 joules. Okay, 3.6 megajoules. So you can also write 3.6 megajoules. Okay. Now power delivered electric circuit depends on what parameters here? Resistance of the circuit. Yeah, power in electric circuit, like you have a bulb, okay, having some resistance, some battery or a cell you connected here. Okay, when switch is closed, current flows through this one, and current in the circuit is V by R. Power delivered across resistor how much? V into I, or I is V by R. So mostly 10th class student knows everyone this one. 8th and 9th students may not be knowing this. Okay, so what you can get? So you can write here V square by R power. Power depends on applied potential, resistance and current. What is current? All of you know very well. Rate of flow of charge. So all the resistance of the circuit, EF of the source, time through which current flows or charge flows. So all the above is the answer. Getting? Yeah. Next we can talk about same amount of work is done by two persons A and B. Work is same. The power ratio is given, right? P1 by P2 is given as 2 by 3. What by power? Rate of doing work. When same amount of work is done, power is what? Inversely proportional to time. So ratio of powers is inverse ratio of the time. So T2 by T1. And this value is given as 2:3 for you. So T1 by T2 will be how much, students? 3:2. Getting inverse ratio. This is right answer. Ratio of time taken to do the work. Okay. More power, less time. Okay. Yeah, one more. Match the following I have given. Right. So work. So work can be here scalar physical quantity or force into displacement. Both answers also you can give here. R and S. And kinetic energy of a body of mass, what is saying? M. Direct formula, half mv square. So you can mark it as a P. Gravitational potential energy. What is the formula given, student? Gravitational potential energy? mgh. So you can write mark as T. Elastic potential energy. Spring energy we have given, no? Half kx square. So you can mark as Q. Power. What is power? Rate of doing work. And power already we defined rate of doing work. This is average power. Or we wrote like this, F dot S by T we wrote, isn't it? This average power, F dot V. Scalar product of force and velocity. So scalar it is a. So power is a scalar. Okay. So like this you can answer basic questions of match them following type like energy, power, work done. Okay. And we have done numericals and power and all here. Electric circuit also. Conversion also we have seen. And simple pendulum energy conversion we have seen. And work done by gravity and inclined plane. Okay. We have seen. And a retarding force and displacement problem we have done when the vehicle is going. And moment change in momentum is area under ft graph we have seen. Okay. And retarding force acts on a body to bring it rest. That question we have did. And work done by centripetal force like gravitational force in planetary motion. And electrostatic force of attraction of nucleus in atom and electron system. Okay. Nucleus electron system also does zero work. Okay. Same model we have done. And work done in a path, okay, by gravity we have done. So some statement, correct statement type, multi correct type we have seen, match the column type we have seen. Okay. So this work done by gravity, again positive negative work done by gravity is negative, work done by applied force positive we have seen. And here, so when a body is moving, work done by kinetic friction negative. Okay, like this we have complete entire. So all the basic numericals of this work energy power. Okay. So please do subscribe the channel and share among your friends, and you can pause the videos, you can solve your questions, and you can verify your solutions. Okay. Thank you all. We'll meet again with the next series. Thank you all. Good day.